My name is Gran. I'm an archaeologist with the University Museum here in Trondheim. And I am doing this presentation on behalf of myself and my colleague Dag Øyvind Engtrø Solem at the Norwegian Institute for Cultural Heritage Research, also here in Trondheim. So what I'm going to be talking about is the idea of identifying crop marks using height data from photogrammetry from drones. And this is based on a project that or a side project of ours in two sites here in the region, where we have been monitoring for several years, two sites with crop marks, and testing out different methods. It's kind of been our test field for different kinds of remote sensing techniques. So before I start going into the data, I want to talk a little bit about the preconditions for preconditions for crop mark detection in Norway. We have a lot of crop mark sites in Norway, but there are some limitations if you compare to our neighboring countries. And if you look at the land cover in Norway, 3% of our land cover is made up by agricultural lands. And if you compare that to, for example, Denmark, you have 62%, United Kingdom 71%, so it is a big difference. And also, with the distribution of our agricultural lands, we see that almost half of our fields are for grass production, and 30% are dedicated to cereals. And typically in Norway, fields with cereals are giving the most crop mark sites. So that is sort of a limitation that we have to work with. But we have a lot of sites, as you will see tomorrow, for the Trøndelag region in large presentation. Also, we have the terrain, and we have a lot of terrain in Norway, so our fields can look very different. So you have, to the right there, you have different types of field systems in Norway. We have areas with really nice flat agricultural land, but a lot of our fields are hills and slopes and ridges. And this affects the distribution of both the topsoil and also older agricultural layers, how thick they are, and this also affects how visible crop marks are. So if you see the illustration with the tractor, this is kind of like how it can look, and you see often we see the really nice crop marks along ridges and tops of field systems where the topsoil is really thin. And this is also often been preferred sites for both occupation and burial mounds in the Iron Age, for example. And then we have to talk a little bit about the weather or the climate. This is our big factor for crop mark detection. And the blue one here is, this shows the precipitation, and the yellow one is the temperature for the last 100 years, or the last, based on an average from 1991 to 2020. And what you can see is that, luckily for us, we have an increase in warm summers, and this distribution of precipitation is quite similar, but we are getting warmer temperatures, more heat, and this also affects the possibility to discover the crop marks. If you see the the ones that are marked in red, this is some of the years where we have been out doing these sites. And the two red ones have been really good years. Very little precipitation and quite hot summers. And then the purple one was a particularly bad year, and we didn't get anything. And the one to the farthest to the left, the single one, the red one, is from 2007, and that was a really good year, and I think we will see some more results from that year tomorrow. So the case sites, we have two sites, one in the north of where we are. You can see Trondheim here. This is where we are now. And to the north in Verdal, we have a farm site called By. And then we have another farm in down just south of the town in Holum. The Holum site looks like this. It's a late Iron Age burial mounds. And these are, there's also several pits and stuff, but I'm going to be focusing on the mounds. So these are the ring ditches around the mound that you can see. And this is a really common feature type for crop marks in Norway, maybe the most common. And this is located on a low ridge along a river valley. And this is very typical for, maybe it says more about the distribution of Iron Age population than it says about crop marks, but you can mark that it is on a ridge, and you have thick layers on the sides of the ridge and little to find there. And these are barley fields. The methods we applied for this is photogrammetry, LiDAR, thermal imaging, and georadar has been used for this site. This is the other site. This is in the north. We have Roman period longhouses, at least 3 of them. This is a quite rare type of crop mark in Norway. I don't know of many that is so visible as this one. So this is an interesting site. It's also located on a ridge. And this has been oat fields. We started, this is the one that has been monitored the longest. We started in 2020, 2021, 2022, and 2022 was a really bad year. We didn't get any results. And then the farmer planted potatoes for a couple of years, so we couldn't do anything. But this year he was back to the oats, and we have been out flying this year. And in this site we have applied the photogrammetry, LiDAR, multispectral imaging, and georadar also, or magnetic susceptibility, I think that was actually. And for this presentation, I will not be focusing on LiDAR or multispectral imaging or thermal. I will be talking about photogrammetry from drones as a method. We have done ground proofing on both sites. They've been surveyed, as I said. This is the Holum, the southern site with the burial mounds. This is the georadar. I think this shows 20 to 25 centimeters depth, so it's quite thin. And then you're on the sterile ground. At the other site, to the north with the houses, we have also conducted a small testing on some of the features, just to see that this is actually historic or archaeological features and not something modern. And we also got a C14 sample from what we have interpreted as a hearth in the building. It dates to late Roman period, and it matches the typological features that we can see in the crop marks really good. So we are now fairly sure that this is archaeology and not something modern. Okay, so I will be talking about using digital elevation models for documenting crop sites. And this method assumes that the differential growth patterns in fields will result in visible variation in crop height, depending on the ground condition, such as archaeology. It's the same that applies for color change in crop marks. And the question is, can digital elevation models acquired by UAVs with photogrammetry method serve as an easy and affordable way to document archaeological crop marks? And is there any way that this method can expand on the scope of traditional crop mark documentation? There are many tools, methods to use when you're working with digital elevation models, and we have been focusing on local relief models or local height models. It seems to be a good approach for these really small variations in height data. This method, you remove the effect of global terrain and you leave only the local height difference. And the way we apply this method is by adding a smoothing filter to the original digital elevation model, and then we do a change detection, and we use that as a base for the DM model. And further, we wanted to develop this model, so we tested using bare ground models instead of a smoothing filter or a smoothing version of the original DEM. for the data set, and that has proved really good. And when I say a bare ground model, I mean that we fly over the site before the crop starts to grow, and we make a base model. So this is some results from 2021. In the top you can see the orthophoto. It's quite hard to see in this picture. Maybe I will do a little zoom in afterwards. But the crop marks are, these are the houses in this area. Oh, you can see them. I will point to the top. There, they are. And then you have the local height model and the local height model based on the bare ground model. And you can see the difference in these two local height models, and the resolution is really quite good on the bare ground model. And here you can see the crop marks in the original orthophoto, and then you can see what we actually see in the local height model based on ground models. So this has proved to be a very good way of documenting. We have had some summers that has not been so good. So this is earlier on in the year. Yeah, this is the same year, a little earlier, 1 month earlier. And you cannot see much in the local height model, but you can, if you look at the on this one with the bare ground model, we can actually pick out the houses here to the top left here, barely. But you kind of have to know that they are there. So, but yeah. All these models, there haven't been any individual tweaking to the models they're all the same settings for reference. And this is this year's capture from the peak when the color starts to turn, and we could not see anything in the local height model. And this year we had a really cold first part of the summer. With very low temperatures and a lot of rain, and this has affected the height, but it does not seem to have affected the color changes. So you can see the crop marks, but you cannot see any height difference. But in the multispectral imaging, you can see them quite well, just as good as the 2001 height models. So this is the other site. We have this is from this year also, and we have the same problem with the cold summer. First part, you can really see the crop marks in the coloring change, but they are quite difficult to see in the height model. But this year we had a really hot last part of the summer, so this is 1 month later, and then we start to see them again, and they are quite visible. We did not have a base ground level model for this site to reference with. We also tried out using LiDAR instead of photogrammetry, and it gives similar results. We have also tried to do first last return and separate the data, but it seems to, in this case, the crops are too dense and we only get first results. So this is something we will work more on. We have also tried some additional methods. So for this last site, we have done a lot of thermal imaging. And this has been proving to be quite difficult, and there's a lot of local factors, time of day, humidity, how much rain the last days before, what part of the year. So it's hard to get consistent results with the thermal data. But the image you see here is actually thermal data, and this is actually with full crop, so it shouldn't really give any good result, but for some reason it does. Could be it's the height data that shines through in the 3D modeling process. The multispectral data is giving us really good results, and it kind of sets the standard, but it's both thermal and multispectral are quite costly methods compared to a commercial drone, ordinary camera drone. So some concluding remarks. I think that height data from UAV photography can certainly be a viable method for documenting crop marks, but it's perhaps better suited for documenting known sites rather than surveying for new sites. It requires high resolution models and it's time-consuming data collection. So maybe satellite imagery is better for finding good years and good data sets and going that route. But for documentation of known sites, it is certainly a good method. It can identify features not visible or barely visible in regular autophotos when the conditions are right. And in years with low contrast, it can help with the documentation. And using a bare ground model as a foundation for the local relief models really has a great advantage. And it gives far more detail than regular autophotos, and it's almost as detailed as the multispectral imaging of the same site. All right, I think that's my time.